Hello everyone! Have you ever wondered how your favorite websites and servers work under the hood? Today we are going to deep dive into fundamentals by building an HTTP server in C. I know there is plenty of videos on this topic, but this video would set the stage for more advanced concepts in future videos. So let's dive into the main material. If you picture the 5 layers of network that proposed by the Cruz book in actually networking books, it is said that we have 5 layers of network, 5 layers of protocols in our network stack. The top layer contains protocols like HTTP, WebSocket, and other protocols, and the lower layers handles connections and transmissions. But today we are going to investigate how HTTP relies on TCP for transmission and communication between two nodes. So let's get started. For creating the HTTP server, we need to take 4 steps. I will write these steps down. First, creating an socket file. 2, binding an address to the socket, specifying the number of awaiting connections, and at the for the last steps we need to accept and actually pop from the queue of connections. So this step would be accepting the connections. So we are good. Let's get started. I've done just created a main file, and I have some other files here that I will explain in minutes. But let's see if our program works fine at the beginning. Yes, building is done and everything is good. It's okay. To create a socket file descriptor, we need to call socket API. Socket API can be included by syscall header file. The socket API actually takes 3 arguments. The domain that could be determined as address family init, address family init 6, and Unix domain socket, address family Unix, and other domains that we are not going to go through them. In our example, we are going to use the address family init that corresponds to IPv4 protocol. So I use address family init for domain. For type, I use socket string that specifies the transmission fashion and transmission method of communicating between one node to another. So we have socket string here, and as protocol we just leave it 0 as protocol. There is no need to set a protocol for socket API, since it infers the protocol from address family and type of the socket. The socket API returns a socket file descriptor as return value, but in error cases the socket returns -1 integer as a return value. So we need to validate if socket file descriptor is equal or greater than 0. To do so, I have just created a simple macro that checks if a condition satisfies. Otherwise, it prints some error and exits the program. That's simple. I leave the link of the code, link of the header file code in the description. So for other thing, I use other that it's not. I should actually include it manually. Errors.h, and here we have is equal or greater than 0, and if failed, we have to print fail to create a socket file, and that's good. So we run our program to if there is nothing incorrect in our code. We make it and then run it, and that's good. But we need to print the failed case or error case in our program. So I change it to -1 and see how the program reacts. As you can see, it prints failed to create a socket file invalid argument. It can just do something like that, but it should be added in a header file. We are not going to do that for now, and just leave it intact. As I said, it printed some error message that we specified, and the invalid argument that is defined in the manual. As you can see, it printed the error message that we specified, and then it prints the error message that is inferred by the error number that is the built-in header files of the C. The next step is binding an address to the socket file. To do so, we need to call bind API, but bind API takes 3 parameters. The first argument is a socket file descriptor that just we have created. The second one is socket address, and the third one is socket length. You may be wondered why we should pass in something like socket length. I have to say that we have different types of socket address. As you can see in the manual, we have a socket family type and socket address data. The socket address could be in type of be type of a generic type that is socket address storage, could be in type of IPv4 address or IPv6 address. So we have a abstract, or abstract is not a good term for this, but we have a generic type like socket address storage and socket address type. So that was just a little bit of verbosity, but let's get focus on the main topic. For our case, we need to create a socket address in type of IPv4. Okay. To gain a socket address, we need to call another function or API that is a getaddrinfo. The getaddrinfo also takes some parameters, as you could guess. The node parameter is your hostname. The service parameter is your port name. In our case, I should mention. The third parameter is hints, that the hints type is of type struct address info also, that could be set in some struct members. As you can see here, you can set some struct members, and it sets a argument that is named result. The result should be left as a null value, so the getaddrinfo fill it up for us. So let's use it. First use this getaddrinfo API. We can see that we have some parameters that we should initialize. So here we have a struct address info we have included netdb struct address info hints, and as a result we should define address info result as a pointer of struct address info. The hints we should memset. Let me std, and we have, oh, what am I doing? Memset. Oh, that's my mistake. Memset address of hints. The value is here and set to 0, and size of struct address info. We should get back to the manual of getaddrinfo, so we take a look at the parameters. So from this manual, we can figure out that we have some struct members that is familiar to us from socket API. What are those? Domain, type, and protocol. As you can see, we have socket type, protocol, and the domain. The domain is equal to address family in socket API. So we set some struct members here as hints. For hints, hints dot address family must be address family unspecified. The unspecified could be address family init 4, init 6, and other address families. But as you can just use address family init for IPv4, but we use address family unspec for gaining IPv6 actually addresses. Also, hints dot protocol should be left to 0. Hints dot address family stack type should be set to what we had here there, socket string, as you can guess, and that address family flags. That's here's an important note that you should keep in mind. As flags, let's search flag. Here we are. For flags, we have some parameters that we should set actually for flag parameter. But the flag struct member is a bit mask of integers, so we can use or bitwise operation for some flags and create a whole address family flags. So we have here some flags that we should define for binding the address. Is address family passive for listening addresses, and we should OR it with AI numeric service. That's enough for now. And what about other struct members? The other struct members is not required for requesting an address. Okay, these parameters are filled up by the getaddrinfo and returns as struct info result. So we just need to set these 4 struct members. We have our address info for retrieving an address info. Yes. So we use it get address info as a host name. We don't need to define it. As the port number, we use 8080, and as a request we use hints that should be address of struct info, and we should address of result that is null and would be filled up by getaddrinfo. What about the return value? Let's check it. The return value says that if the value is set to 0, it's succeeded, and otherwise it returns an error number. So we have to check this status of the return value. We should assert that status is 0, otherwise fail to get address info. So we are done here. There's no need for testing out. Let's take our step further and use the result of getaddrinfo API. To do so, we need to iterate on the results of getaddrinfo. The getaddrinfo, the address info struct has some struct members that is imported here. It's address info next, canon name, address, and address length. The canon name is not used for our case, but we use address info next, address, and address length. Let's see how it works. Now we need to iterate over the result of getaddrinfo. The result of getaddrinfo is a linked list. So for iteration, we need to initialize another variable that we can call result pointer. The result pointer is an index of the linked list, so we can iterate over using that. So we can do so until respond null, and for the action of iteration we can say if you may say that why we are not using the result for iteration. I should say that the getaddrinfo allocates some memory for the result and the linked list, so we need to free it as we are done with the linked list. To access the first element of the linked list, we need to reserve a variable for the first element and another variable for iteration over the linked list. So here we call free address info for result. The next step is binding the address that one of the found address to the socket. So we can call bind sfd, and we can say also the bind returns an integer as the status of the operation that is done by the bind API. So we also check for the status. We can just assert the result of bind in one line, but for sake of readability, I just separate them in two lines. We should assert a status. Yeah. And here we assert that resp is not null. What does this line mean? It means that we shouldn't reach the end of the linked list. The end of the linked list. So we have found some addresses for binding to the socket. So far so good. Let's see how it works. It doesn't work. Oh, we didn't fix the protocol here. Failed to resolve the address. So we have to check why is this happening. We have checked. We should break. I just missed the break, and everything is fine. So we need then the third step is to listen to call the listen API. The listen API is very simple. It just takes the socket file descriptor and the backlog that shows the number of connections that can be awaited for handling. So we can call excuse me, listen here for socket file descriptor, and say 10 number of connections can be accepted. Status and so, and the last step is to accept or pop the connections from the queue and handling them. For this purpose, we can say, what am I doing? Just say while true. So here we have to accept some actually connections. We accept from server file descriptor, and we leave these parameters null for now, and I'll explain them in minutes. The accept API actually returns the client file descriptor that we should send and receive messages data from and to it. To and from it. I made a mistake. So we can call it client file descriptor, and like socket, we should assert the return file descriptor by asserting badges. Let me check. On success, this system calls return the non-negative. As we select, we should check if CFD is greater than or equal to 0, and fail to accept the connection. So far so good. And the next step is just reading from the connection. That's so simple. Let's define some buffer here. So initialize the elements of the buffer to 0, and let's go ahead. Let's read my bad, it's not std. It was so we can easily read from the client file descriptor and print it out. That's simple. The next step of it, so let's keep this simple and do it step by step, one by one. Let's read it, and we have to store it in buffer and say just size of buffer, and also we need to check number of data read could be something like rather than other numbered fail to read the data, and just we are going to print out the data. Oh, that's okay, and that's it for now. Let's build and say yes. As you can see, we have sent our data to the server, and the data is shown from the server process. And I just forgot to close the connection. Another initialization of connection should be taken place, and here we have hi and done. Everything is good. The connection is accepted here. Read some data and then close the connection. We can just write something as a response to the client. So we have write for client file descriptor, and how about to write back the data that is sent from the client. I think that's okay. So we have to write buffer and in extent of num read should be sent, and we have here number of written bytes. We have the same alert here, but for num write, fail to write the data, and that's good. Spin up the server, make the connection, send some data, receive back data, and everything is good. So that's good for now, but we have just created a TCP server and client for our example, but we need to create an HTTP server. The HTTP server is the HTTP server must be handling the request with some proper and structured text-based response. So we create a constant for the response, so there is no dynamic response based on the request of the client. We have and here for our HTTP server that says we are going to respond with HTTP 1.1 version and say everything is okay. CRLF. Next line is next line. Say content length, and we should repeat this line and say okay. That's good. So here we have nothing for changing and we just need to write the response instead of the buffer. So we have what we have response, we have length of response. Yes, we have response and number of writes, and everything is okay. So we spin up the server, but here we have to, no, we don't have to. It's just easier to create a shared request instead of create a manually structured and constructed request by netcat. So we create a request by curl localhost 8080 and every path you want. That's good. We have received the request. As you can see, that's the content of the request, and this is our response. To inspect the headers of the response, you can just enable the response headers by enabling the I flag for CRL for curl. And as you can see, that's just working well, and we have our HTTP server that receives some HTTP requests and respond with okay content. But this server is not actually some practical and useful if you want to deploy it or launch it somewhere on your server. I just want to handle the requests gracefully and separately in a readable and actually more structured way. So I want to create a function that returns some status, say it handles the request and takes in client file descriptor. So we just want to transfer these lines of code from the main function to handle request, and we can call handle request here. Oh, we have not defined. So that's good, and oh, we should move the buffer here. You can just pass in these three variables to the handle request, so you don't need to actually define on every iteration of the handling connections, and just use the same memory for the buffer and number of read and write data. But for sake of simplicity, we just move them into the handle request. So let's see if everything works fine. Shouldn't hazard here, but that's fine again. Yes, that's worked fine, and there is no breaking changes. Now we have our HTTP server done, but it's not doing so much. So for adding some functionality to make it more useful, we can do two another steps and see how it works and how it functions. The fifth one is printing out the client and the server address. And the sixth one is making JSON response and this one sent to the client. And that's very nice. Make an HTTP response. So for this step, we can just we have to convert the network form address to presentational form address. Here we have an address that is in network form, so we have to convert it in another form so we can print it out. Here we use an API called, let me show you. This API, this function takes in address in network form and converts it in representational form, as it implies from the function name. It stands for Internet Network to Presentational or presentation. So here we call it and see how it works. We have init into p. We have address family of. We can just use, since we have already checked in the condition above. Yes, above. And passing the address. So the point here is that we have to convert the generic type of address family address to internet address. I mean, here you have to create a socket address internet which corresponds to IPv4 address, and it should be in type of it should be a pointer of socket address internet. So we call it address and say we want to cast result pointer address. Since the address info address is pointer, so you don't need to reference or use ampersand for getting the address of the value. You can cast directly the type to start socket addressing. The next action should be using just this address. So we say init into p, we have address family init, and say we are giving address socket internet address, and the buffer. Oh, we have to define our buffer here and say we have a host that contains net address strlen, and it is filled up with zeros, and we are passing it here, and the len also should be address strlen. We have so far so good. But we can check also the result of the init into p. I create a const char test and assert if test is not null init into p. I just don't feel like writing all this phrase here, and that's good. We are filling up here, and we also can have as port that is here, and we also can convert the network form to integer form of the port. So here we have port n2 that takes in a unit 16. So as a network form of the port, we can pass in your port and your port. So here instead of actually putting the static address of the server that is that's going to be up and running, we are using formatted string to print out the server address. So here we have a string and an integer, and use host and port. So I just put the return here, so we can just check that if our this part of the code is working well. Yes, that's working fine, and let's remove this line and get to the client address. The client address, as you can see here, we have the accept that takes in an address and address len. So if this value is not set to the null, we can just pass in some address and address len, so the accept will fill up and initialize these values for us. So here we can just say that we can have an address here, say here and C J here, and the address len must be no, let me check the sample. It's cycling T. Say we have a client address, len is size of cycling T. This could be, and so we have to convert it. ADDR len, and say we have a socket address. I have just made a mistake, and that's right. So we can also print out the value that is initialized by the accept function. So we just copy this line and client address here is port, and close it. Here we have, so we have here the address, but the point is that we have to also convert it like the lines we have here. So also we copy these lines, paste it, and say we don't have a result pointer here, so we have yes, we have the address. Instead of here we have we can just directly use a client address. I think that's much easier to write it. And we can reuse the host and in as a port. We can just use C. Yes, that's working fine, and let's test it out. And that's just no, it's not working fine. Let me see what's my mistake. So I found the mistake. The mistake was that the size of the address len is not, it wasn't correct, because that wasn't this. Let me change it back to the previous state and say that. So here we can try it out and say what's the incorrect part of the code. As you can see, we are printing 0000 for the I've just confused everything. We have connected, and you can see that we are printing out the right IP for the client, since we are aware that this is not the correct IP. So the valid address len for the client is not the cycle length, it's the size of site address internet. So we use unsigned integer for the len and say that we have len, and so far so good. Let's spin it up, and that's correct. So this step is also done. The next step is making a JSON response. The JSON response is such an easy task. I just want to accomplish it for making a more useful HTTP server. Say we have an object like that. The first key contains id line. The id line represents the NC doesn't work here for us, since we need to create a real HTTP request. So we curl localhost 8080. The ID line is the line that contains the method, the path, and the version of the HTTP. So we have here. The next key is headers. The headers is an array of strings. So we have this line. What did I just do? and that's good. Oh no, that's not good. And the next key is just the body of the request. It can be everything that you send through the HTTP request. So we have to create something like that. Say we have, say what we have. We have hello. Here the body contains just a string equals to hello. And that's it. There is nothing about socket programming and networking APIs here to mention. It's just creating a simple string and send it by the right API, right syscall. That's it. So I just write the remaining code, the rest of the code, and if there was any points through the writing the code, I would explain it. So we just can. Oh, another point is that I have created a simple string library here, a string header. It doesn't cover many cases for a string, since we are not creating a full-featured string library. We just need to create a header and some functionality so we can create our JSON response here. So here are our functions. So let's get back to the handle request and say we are going to write and create our HTTP response. Another point, I'm just recalling the points. Another point is that we want to validate if our HTTP request is fitting in 1024 bytes. So if it exists this size, we are going to respond with that request. So let's first implement it. First we can create our bad request. We can also, as a header of HTTP response, add content type, and also add this line for the bad request. But since the length is different from the OKSA tools, we need to get the length, and that contains 25 bytes. Let's make more informative. The length of request must not exceed 4 bytes. We have no need for bytes. Dots and now let's implement first the validation of the HTTP request. The HTTP request must be handled in this way. Just say that request read buffland buff, and here we can make use of a function called ICTL. The ICTL actually can help us with finding out if there is any bytes and data left in the buffer of the TCP connection here or not. If there is any bytes remaining in the buffer, we send back an HTTP response with that request, and otherwise we just continue the program so we can create our response and send it through the connection, HTTP connection. And we can use IOCTL for client file descriptor, use the flag IO and read, and say we are going to read here, and say so let's use 4x4 buffer length so we can get we can satisfy the condition that the request length is more than our buffer length. So let's run the server and create our request. So, oh, just made a mistake. And what's wrong? So the error was here that I didn't save the file, and also there was a typo here that was something like that. That was just this, and we need to fix this to the correct contentless header so the curl request can identify the length of the response, so it can print and say that everything is okay for receiving the response. Let's try it out. The length is here correct. Oh yes, and that's all right. And we can add iflag for getting the headers of the response. So far so good. We set the buff length to 1024 and write the rest of the program. From now on, we are going to create a JSON response from the HTTP request. So let's write it. So here I used some functions from a header file that I provided here for our HTTP server. It doesn't cover all the cases for a valid string that you may need for a production ready program and your also daily basis program. So this library, it's not in extent of a library. There's only 4 functions that I needed to use for my HTTP server. That's just creating a new string, appending some string to appending some character array to a string, and free the allocated memory, and just converting the string to character pointer. And that's it. There's nothing complicated about it, and you can just check this code out whenever you want to. So here we just responded with the empty object of JSON through the response. So the first key of our response is ID line. So we have to loop over the request that we have received from the client and extract the ID line. So let's do it. So we need to create another and define another variable here to store the body of the response. Since we need to find out the content length to set as the content setter, we have to build up the body of the response and then extract the content length and set it to the header. So we have to define two variables, two strings actually. We change it to body, and here's our body of the response. Then we define the response. That could be I think that's okay. Oh, what's that? I just forgot to break. Yes, first step is done, and let's go for the rest of the JSON response. So here we accomplished extracting the ID line. Next step is to extract headers of the request. I can just copy it, but we have to remember that this index is shared between the loops. These loops are loops for extracting ID line, headers, and the body. So we have to keep it global for actually these blocks and here. And we have here. Yes. But here we have to say that append body. Mistake. My mistake. I think that's not a clean solution for that, but we'll fix it later if was required. and the header section also is working. And the next key is the body of the request that should be stored in the body key. So let's go for it. And that's okay. And I know there is no need for sharpen, but for retaining the same structure of the loops, I just keep it. But you can just remove it. There's no need for it. But also you can keep it. And we have appended the buffered body, appended the double quotation, and that's just it. No, there's no need. And the next key also is done. So we have an HTTP server that takes the HTTP request, as you can guess, and responds with the whole request, and actually structure the ID line, header, and the body as a JSON response, and return it back to the client. And just let me do this, and it's okay. So our HTTP server is ready, but there is a point that I'd like to mention, and that's the memory leak. How can you check the memory leak in your program? I do this in this way. So let me show you. Let's just break after handling the first request and exit the program. Let's just delete. Okay. Yes, it handles first request and exits. We want to check if our program has memory leaks. So I comment one of the allocated strings here and run the program. First build it and then run it. Request, send request, and it's okay. The tool named Valgrind, if I'm pronouncing it correctly, can help us detecting and spotting the memory leaks and memory leaks in our program. So let's use it. Make use of it to check if our program has any memory leaks. I type in Valgrind-s and say my program is main, and send the request. As you can see, Valgrind reveals the memory leaks in our program, but it asks us to actually enable a leak check full for detailed information about the memory leak. But we want, as we know that where is the problem, we can just fix it easily. But the point of this action is that is to show you how Valgrind works very overally, not just a detailed description of the Valgrind functionality. So here we have a heap summary, leak summary, and the suggestion for using options of the Valgrind, and you have some error summary here that tells you about the errors in your program. as you can see here, we have a 272 bytes in 2 blocks and other information here that says about memory leak and program. Let's see how Valgrind tells us about the memory leaks and how exposes the information of the information about the allocation of in our program when we free the string here, and it is expected to prevent the memory leaks of the program. So let's build again. As you can see here, Valgrind tells us we have 19 allocates, 19 frees, and 8,344 bytes also is allocated. And here's the important part of the information that says no leaks are possible. As you can see, we have freed the allocated memory, and there is no there is no data wasted here in our program to be cleaned up by the kernel. That's it. You can just check your memory leaks in our program as we did here, and we have our HTTP server that also has that responds with JSON content and also has no memory leaks in it, and works fine and well. Here it is. Thanks for watching my video. I hope you have enjoyed the content, and that's it. Catch you all later. Bye.